In recent months, volcanoes around the world have erupted at an unusual rate. From the Pacific Ring of Fire to Africa's Rift Valley, dormant and active volcanoes alike are producing ash clouds, lava flows, and seismic tremors. Scientists are tracking these eruptions in real time, using satellites and sensors to monitor every event as it happens. The data shows a clear increase in volcanic activity across multiple continents and oceanic regions. This global surge raises a critical question. Is Earth entering a new cycle of volcanic activity, or are these eruptions part of a normal pattern? In this video, we'll examine the evidence, explore scientific theories, and ask what these eruptions mean for our planet's future. Let's get straight to the facts and uncover what's really happening beneath our feet. The past year has felt like a planetary drum roll, a steady buildup of tension echoing beneath our feet. Around the world, the Earth's restless energy has been on full display, reminding us of the immense power that lies just beneath the surface. One after another, Earth's most formidable volcanoes have burst into life, sending plumes of ash and rivers of molten rock skyward. It's as if the planet itself is making its presence known, demanding our attention. In Russia, Kamchatka's giants have painted the sky with ash and fire, their eruptions visible from space and felt by communities living in their shadow. In Indonesia, eruptions have forced mass evacuations and disrupted lives along the volatile Ring of Fire, a region notorious for its seismic activity and unpredictable outbursts. Hawaii's Kilauea has dazzled with dangerous lava flows, reshaping the landscape and captivating scientists and locals alike with its relentless energy. In the Americas, Colombia's Nevado del Ruiz and Mexico's Popocatépetl keep millions on alert, their rumblings a constant reminder of nature's unpredictability and the need for vigilance. Each eruption is unique in its power and impact, but their near-simultaneous activity is what truly grabs scientists' attention, sparking questions and urgent research worldwide. Is there a hidden conductor, a planetary force linking these events? Or are we simply witnessing the unpredictable rhythm of Earth's geology, a reminder of forces we barely understand? The clustering of eruptions is a statistical curiosity demanding explanation, pushing scientists to analyze patterns and search for connections that might reveal deeper truths about our planet. When several major eruptions happen together, their effects ripple across the globe, altering weather, impacting air travel, and even influencing global temperatures for months or years. The Earth is reminding us it's a dynamic, ever-changing system, one that commands respect, awe, and constant curiosity from all who call it home. To understand why volcanoes erupt, we need to look deeper than the fiery spectacle on the surface. We must journey beneath the surface into the hidden world beneath our feet, where immense forces are constantly at work. Earth is layered like a giant cosmic onion, a solid inner core, a swirling molten outer core, a churning mantle of hot rock, and a thin, brittle crust that forms the ground we walk on. This crust isn't a single unbroken shell. Instead, it's fractured into massive tectonic plates, floating and shifting atop the slowly moving mantle below. These plates drift apart, crash together, and grind past one another, creating zones of intense geological action, from earthquakes to mountain building, and, of course, volcanic eruptions. Most volcanoes are born at these boundaries, especially where one plate dives beneath another in a process called subduction. Here, the descending plate is forced deep into the mantle. As it sinks, water and sediment trapped in the plate are carried down, lowering the melting point of the surrounding mantle rock and causing it to melt into magma. This magma, lighter than the solid rock around it, rises upward, searching for cracks and weak spots in the crust. When it finds a path, it bursts forth in a volcanic eruption, releasing pent-up energy from deep within the Earth. The Pacific Ring of Fire is a dramatic example, a vast chain of subduction zones circling the Pacific Ocean, driving eruptions from Indonesia to Russia, and making this region the most volcanically active on the planet. But not all volcanoes form at plate boundaries. Some, like those in Hawaii, erupt far from any plate edge. These are known as hotspot volcanoes. Here, a powerful mantle plume, a column of superheated rock, rises from deep within the Earth, acting like a blowtorch that melts the crust above and creates chains of volcanoes as the plate moves overhead. Kilauea is the latest in Hawaii's volcanic lineage, a direct pipeline to Earth's fiery interior, and a living laboratory for scientists studying volcanic processes. Understanding the interplay between plate tectonics and hotspots is key to deciphering our planet's recent fiery behavior and predicting where future eruptions might occur. These processes, tectonic movement and mantle plumes, are the engines of Earth's volcanic activity, driving the creation and destruction of land over millions of years. The more we learn, the closer we get to understanding the planet's restless heart and the forces that have shaped, and continue to shape, the world we live in. The story of eruptions is written in the movement of the Earth itself, a never-ending cycle of creation, destruction, and renewal that connects us all to the dynamic planet beneath our feet. We know why volcanoes exist, but why so many eruptions now? Tectonic plates move slowly, so what could trigger simultaneous activity? Some scientists wonder if large earthquakes send seismic waves that disturb distant magma chambers, like tapping a pressurized can. Others look deeper, to mantle currents, vast flows that might influence multiple regions at once. Seismic tomography is helping us map these hidden currents. Of course, it could all be coincidence. Clusters happen in chaotic systems. Scientists use statistics to test if this eruption cluster is truly unusual. If so, we may be glimpsing a deeper planetary connection. Let's look beyond Earth, to the sun's influence. Solar storms send charged particles to Earth, creating auroras and powerful telluric currents in the ground. Some researchers ask, could these electrical currents influence volcanic or seismic activity? The theory is controversial but intriguing. Could a solar jolt destabilize magma or lubricate faults? Early studies show some correlations, but causation is unproven. Scientists are building models to test these cosmic connections. The mainstream remains skeptical, but history shows today's fringe can become tomorrow's fact. Exploring these ideas reminds us Earth is part of a vast, interconnected system. One region demands special attention: Ethiopia's Afar Triangle. Here, eruptions are happening above the African superplume, a colossal upwelling of hot rock from deep within the Earth. This superplume is literally tearing Africa apart, splitting the continent along the Great Rift Valley. Recent eruptions suggest this process may be accelerating, the birth of a new ocean in slow motion. These eruptions are windows into the deep mantle, offering rare samples of Earth's interior. Studying them helps us understand how superplumes shape continents. Some speculate a surge from the African superplume could influence volcanic activity worldwide. It's a reminder that Earth's mantle may behave as a single connected system. Erupting volcanoes are awe-inspiring, but for millions they're a matter of survival. We can't stop eruptions, but we can prepare. Starting with science. Volcanologists monitor ground movement, tremors, and gas emissions for early warnings. Effective alerts and evacuations depend on clear communication and trust. Communities near volcanoes need emergency plans, knowing routes, having kits, and understanding local hazards. Ashfall can travel far, disrupting life and health. Preparedness is essential everywhere. Recent eruptions show how interconnected our world is. An event in one place can affect us all. Living on an active planet means respecting nature's power and investing in readiness. We're witnessing a spectacular moment in Earth's story, and in our scientific journey. Are these eruptions isolated, or connected by hidden threads in the mantle, or even the cosmos? Some ideas are well established, others are bold frontiers, but all are part of the scientific process. Curiosity drives us to ask questions, test ideas, and seek understanding. The more we learn, the better we can live in harmony with our restless planet. Today, we've glimpsed Earth's fiery heart and its mysteries. The story isn't over. Its most dramatic chapters may be ahead. As we watch and learn, we're not just studying a distant object, we're studying our home. Let's keep exploring. Together.